Right, we've got P4, International A-Level, October 2022, question 8. Got one of the old Rsinx alphas here. So we express it in that form, standard thing. And then we've got this function with the tribute on the bottom. We're going to minimize it and find the x value, and then a couple of odd questions at the end, but we'll get to those in a minute. So we're going to express 8 sin x minus 50 cos x in that form. If I look in the formula book, this is what it says for sine of a plus or minus b. Well, I need sine of x minus alpha. So I replace the a's with x's, b's with alphas, and use the -1 multiplied through all by r to get the r sine x, but then I get it in this form, and that's got to match up with this. This is the cos x term, so these are going to match up with each other. So that r sine alpha must be equal to 15 if they're going to match up, and the same with the sine x term. R cos alpha must be equal to 8. A few ways of solving this. Some people like to draw a triangle. The way I like to do it, if I square this top one, so like r squared sine squared is 15 squared, and the bottom one, r squared cos squared is 8 squared, and add the two together, I get this. I can take an r squared out as a factor, and the right hand side is just 289. I forget about this this bracket, because sine squared plus cos squared equals 1. So the r squared is 289, so it gives me an r of 17. If I divide the two equations, I'll have r sine alpha over r cos alpha. Those r's cancel, so I'll just have tan alpha equals 15 over 8. I'm going to do tan to the -1 radians, 4 significant figures. I get 1.081. These are the sort of 4 possibilities they might ask you, and you just got to remember that you do the b over the a rather than the a over the b. The only issue I can see is that if these two, the top one and the third one, are really the same, something's like sine plus something cos. So they wrote it in this form and then asked you to put it in that form. Then, well, that would be a bit evil, really, but you would get it wrong. But it's never happened, so don't worry about it. Just do the b over the a. Right, then part B, we've got f of x equals 15 over all that. So I can write this bottom line using what's in the first part, because I've got 16 and 30. I can write it as 2 lots of the 8 and the 15, which is what I've worked out before. So I'll have 34 sine of x minus 1.081. That's my f of x in a form that I can minimize it. And if I want to minimize f of x, I need to maximize that part, the sine. The sine graph goes up to 1 and down to -1. So the most the sine of anything can be is 1. So the minimum value of this is when the sine of x minus 1.081 is equal to 1. So the minimum value is 15 over 41 plus 34, which is a fifth. It occurs, like I say, when the sine of x minus 1.01 is equal to 1. And that's here where the x is pi over x minus 1.081 is pi over 2, giving me x is 2.65. And then it says state the y coordinate of the minimum point of the curve with that equation. Well, if I draw a little minimum point here, this is my minimum point. It's got a y value of a fifth, an x value of 2.65. And if I do this function, so this is like f of x really. If I do 2f of x minus 5, the 2, well, that's going to double the y values. So it'll be 2 lots of 0.2. It'll be up here somewhere. And then take away 5. That moves it down by 5. So subtracts 5 from the y value, giving me minus 4.6. And then the last part, minus f of 2x. F of 2x, well, that's a squeeze towards the y-axis. It halves the x values. So the x value here is going to be half of 2.65, which is about 1.33. Y value stays the same, though. And if I do the minus of it, it's a reflection in the x-axis, because all these positive y values become negative then. So the coordinates of this point, 1.33 minus 0.2, and that's a maximum now, which is what I want. So you get a mark for writing down 1.33.